For this question, we have lightly doped p-n junctions break down at lower reverse voltages than heavily doped p-n junctions. We're going to be looking at the notes that are linked below the like button when we're addressing this problem. So we have lightly doped p-n junctions. They are going to break down at lower reverse voltages. This is what we're looking at. Lower reverse voltages, and then we have heavily doped p-n junctions. And so we have our reverse breakdown here. If the reverse bias voltage across a p-n junction gets too high, the junction is going to break down. So if it's at high, we're going to have the breakdown. And it's asking us, the lightly doped p-n junctions break down, and it says at lower reverse voltages. Well, it breaks down if the junction gets too high. So we have heavily doped p-n junctions. So obviously, this statement is not going to be true, because this statement is saying that lightly doped p-n junctions break down at lower reverse voltages than heavily doped p-n junctions. Where this one is saying, and this is from the notes, if the reverse bias voltage gets too high, too heavy, it breaks down and the current increases rapidly. And then if we are talking about the voltages, we can also look at more of the notes that are up here where we deal with E, and E is with up here. We have a graph right here, or a diagram right here, and we have our barrier region inside of here, and then we have the E, which is just the voltage, and I believe times the current, something like this, where we have our potential and the barrier of the voltage. But that is more note stuff, and that was the answer to this problem. So for this one, it is going to be false.